In this example, we are given the yield in grams from a chemical experiment corresponding to an input of grams of a certain substance to the process. From the question, we can deduce that the yield y is clearly the dependent variable, whereas the input x is clearly the independent variable. This is a correlation and regression question, where from the question itself, it is clear that one variable clearly depends on the other, and in particular in this case is y that depends on x, so eventually we will only be interested in finding and using the regression line of y on x. That's something we have to take note at the start of the question. In part A, we are supposed to obtain the least square estimates for alpha and beta using two equations. The first one, y equals to alpha plus beta log x, and the second one, y equals to alpha plus beta x squared. To approach the equation in part 1, first of all, we let z equals to log x. So this means that we are interested to find the least square regression of y on z. We go to the GC, go to stat, and go to edit. As you can see, we have input the values of x into L1 and the values of y into L2. However, we are interested in the values of log x. So we go to L3, we key in log L1. Enter. So now we have all the corresponding values of log x in L3. We go to stats, go to calculate, go to linear regression a plus bx. My x least contains the independent variable, in this case is log x, so we key in L3. My y least should contain the least of dependent variables, in this case it's L2, and then we calculate. And we find that a is 22.6, b is 73.6, a and b correspond respectively to alpha and beta. Take note also that my r in this equation is 0.887, which we will have to use later. So as you can see from the solutions, alpha is 22.6, beta is 73.6. For part 2, the regression line we are interested in is y equals to alpha plus beta x squared. So now we let z equals to x squared. We go to the GC, stats, edit, go to L4 now, and then now because the variable we're interested in is x squared, so we key in L1 square, input, enter, and then we find all the corresponding values of x squared in L4, go to stats, go to calculate, linear regression. In this case, x least, the independent variables is in L4, y least is still in L2, so calculate, and this is what we get. And take note that once again that the value of the correlation coefficient is 0.835 for the example in part 2. So as you can see, alpha is 66.6, beta is 0.331, as we could see from the interface of the GC earlier. The next part of this question requires us to determine which equation is a better fit, giving reasons to support our answer. This is an question which is often asked, and to be able to determine which equation is a better fit, we need to compare the values of r in each case. So from earlier, we have found that in part 1, r is 0.887, whereas in part 2, r is equals to 0.835. So as a result, because the correlation coefficient for part 1 is larger than that in part 2, what it means is that there's a much better positive linear correlation when we use the equation in part 1. So therefore, y equals to alpha plus beta log x will be a better fit. The last part of this question requires us to use a suitable regression line to estimate the value of x for which y equals to 69. And we are also supposed to comment on the reliability of our answer. So because y equals to alpha plus beta x has been found to be a better fit from the earlier part, it is the regression line we are going to use. All we have to do is to sub y equals to 69 into the equation in part 1, and then we solve for x. We found that x is 4.27. Is this estimate reliable or not? In fact, it is. Why? Because we have used a regression line which is a better fit, and meaning it has a high correlation coefficient. Because y is dependent on x, So we have to use the regression line of y on x, and eventually the value of y that we sub in actually lies within the data range from 65 to 95, meaning we have used interpolation. So therefore, we can conclude that the estimation is reliable.